Hey everyone, my name is Abe, and today I'm going to be talking about one of the most important shifts in the way we work with databases today, the move from simple queries to AI agents. So if you're a builder or someone who just loves to make apps on the side, you can stay for this talk. Hey everyone, welcome to the talk. So we're going to go from queries to agents. I'm going to talk about the next era of data retrieval on Postgres. As you folks already know, my name is Abe Omorogbe. I'm a product manager on the Azure Postgres team working at Microsoft. I have some previous experience on the Azure AI team plus Databricks, so you can say I've been in the AI trenches for quite some time now. Last year in Posette, I talked about building intelligent apps with graph-based RAG. Consider this a sequel. We're going to talk about how to build on top of that, but now with agents. So if you guys want to follow me on socials, they're all on the screen. So let me ask you guys a question. Has an AI agent ever done something you didn't want it to do? Maybe giving you an insufficient answer, perhaps it deleted a database or some data you didn't want, or maybe it exposed some information you didn't want exposed to customers. If you're nodding your head, you're not alone. These are some articles I've picked up over the last years about agents misbehaving. One cool one I saw was an AI agent destroys this coder's entire database. He's not the only one in this horror story. So clearly it's happened to a lot of people. But the one I want to focus on for this talk is why 90% accuracy in text to SQL is 100% useless. So that kind of goes to the crux of this demo. It's kind of talking about if the agent creates SQL for you, is it actually something useful for your data retrieval? I'm going to give you guys a more practical example of that. So instead of sensationalized headlines, let's talk through a use case that happened to me. So what happened is I gave my AI agent access to my product database, and I asked it a very simple question. What's our best product? Now, it confidently answered with something, which was an insufficient answer. It was a plastic bookshelf that it's pretty rickety and is actually our very cheapest product, not the best product. So how does the agent know the difference between best and cheap and so on and so forth? The model is really good at creating the SQL. However, the problem here is retrieval. How can we solve this? So what I want to walk through today is I'd love to show you how we can kind of address this problem of giving me more sufficient answers with Postgres step by step, and how you can build trustworthy AI agents in Postgres. So let's get started. So what I'm going to do is I'm going to walk through the going from RAG to agents, the introduction of MCP, common issues that you would see when it comes to using agents for data retrieval. Then we'll talk about context correction, and then I'll talk to you guys about what's next in the space, especially at Microsoft. So right off the bat, I just want to level set with everybody. You're probably already using RAG tools already, but let's just level set. RAG is retrieval augmented generation. If you haven't used this before, simply put, how it works is a user puts in a query. We do a vector search. The vector search is part of the context that gets sent to the LLM to answer the question. And you get a grounded result on your data because the vector search was done on your data. It works great. However, it is single turn and it only retrieves. If a user wants to, ask a question or a prompt that's a lot more complex, how can we do that with RAG? It's pretty hard. So if a customer asks, I'm redecorating my living room, find me a stylish bookshelf under $100 that pairs well with a Forino end table, and check if any similar storage furniture is a bargain. This is a super complex query, all chunked into one. RAG can only search this as a whole, provide the context and give an answer. However, what the user wants is it wants a semantic RAG search. The user would want price filtering under $100. User would want the app to traverse a graph and find things that pair well together. And lastly, the user will want you to also do a bargain check. RAG gives you that one step. However, an agent will give you all four steps in one. So let's talk through what this agent architecture actually is and what that looks like. So instead of that single retrieval we saw in RAG, it's a little bit more of a multi-step approach. What happens with an agent is the agent takes in the query from the user. It pipes that query into, it looks at tools that can solve the query. So for this example, let's say we have a SQL query tool that can go to the Postgres database and query SQL, graph retrieval tool, vector search tool, and other tools that may be useful to answer the question. The agent picks the tools it needs, and then it answers the question using the help of an LLM, synthesizes that question, and gives the response back to the users. The most important step here is the tool layer. And it's the most important and most interesting step, but it's also where things can actually break. But before we talk about how things break, let's quickly touch on how exactly can Postgres even talk to these tools. So before we head on to the failure modes of this approach, let's quickly talk about model context protocol. This is the way that tool layer can actually seamlessly talk to Postgres. So what is model context protocol? What it is USB-C for your AI. So the way to think about that is how an agent can get access to different types of tools. The reason it's called USB-C is because it's a standardized protocol across all AI agents and all frameworks. So instead of each framework redesigning how your AI agents talks to a tool or a data store, now there's one open protocol to do all of that. And this is a growing ecosystem. Like MCP servers for Postgres already exist, and you can start trying that out today for an agent to connect to your Postgres server. This connection from agent to MCP and Postgres gives structure to the agent, right? It tells the agent, hey, this is the tool you need to call, this is how you need to call it, and this is what you need to return back. However, does the agent really prepare good queries? So that's the issue we start to find a lot of the times. Let's stress test this example and walk through some common failure modes or common issues that come up. If we use that same query about, redecorating the living room with a stylish bookshelf under $100, what is required from that agent is to call several tools. It needs to call the vector tool, the SQL tool, the graph tool, as well as do some multi-step. And here are some things that could possibly go wrong because the LLM needs to predict the generate the SQL based on just this query. So what could happen is first failure mode is hallucination. So the agent can generate SQL that actually doesn't even exist in your table. A good example of this is the agent could generate SQL that says, hey, get data from my products recs table, a table that may not exist at all. And that would probably throw an error. The second failure mode could be this semantic misunderstanding. Like I said in the top of this, the agent doesn't really know what things could mean. Like, for example, if I were to say stylish bookshelf, the agent may think, hey, stylish bookshelf, I can do I like query and I can find anything with stylish bookshelf in it, and that's answering the question. However, for me, that is not correct. Like, I wanted my agent to check for modern bookshelves, sleek bookshelves, and chic bookshelves because that all ties into the word stylish for me. So instead of returning 400 results, it only returns 8. The third big thing that we see come up a bunch is just completely missing guardrails. So a good example of this is your agent generates SQL and exposes internal data. For example, here, imagine the agent generates SQL, it doesn't know what it can show and not show, and it mistakenly shows wholesale price. This is not good for your customers, and clearly, with no guardrails, the agent is not production ready yet. So what I want to do today is walk through how we actually solve these problems. The problem is not with the SQL generation itself, it's actually with the context. So what's happening is the agent is producing SQL based on, what it knows. However, if it doesn't have context in your specific database, it's going to make a ton of mistakes. So how do we fix that? In Postgres itself, what we can do is we can apply a step of context correction. And the way I like to think about this is there are 4 different layers we can apply context correction to. The first one being schema context. First, you have to give the agent context around your schema. What tables mean what columns mean what, not just the name. So when the agent looks up the schema of your database, it understands what each thing means and the context behind it. The second thing is semantic context. Your agent needs to have some semantic understanding of when a query comes in. So, for example, if I were to search stylish bookshelf, as I said, the agent needs to know I also mean modern, sleek, chic. If I were to search something like cheap or low in price, it should know it's below a certain price. The third thing is relationship context. So, you also want your model or your LLM or your agent to understand how things are connected, how product reviews, categories are all connected together. So you need to give it context about that. And then lastly, you need to give it context around safety and governance. What are allowed queries? What can the agent do or not do? Can it delete rows? Can it not delete rows? Can it insert? So on and so forth. So with all these four layers, you can start producing, a more trustworthy agent. So what I want to do is I want to start with a demo data set so we can all kind of wrap our heads around what's going on. So I'll show you guys, this is the, e-commerce data set. Imagine you have an ID column, name column, brand column, price column, an embedding column, right? As well as categories that show everything in this database. The first thing we can do directly in Postgres is we can add context actually directly in Postgres. So all you need to do is when you're setting up your database, you can just add a comment to a column and describe what's going on. So this example here for the category column, I'm describing the context of that column, what exactly it is, the data type, so on and so forth. The second thing you can do to apply context is, as I talked about, the semantic context. One pattern I like to use is using a semantic dictionary. So basically, if a term comes in, like the term I said, stylish bookshelf, what you can do is you can tell the agent that, this also means all these other things. And you should expand this search term when you're searching anything with stylish bookshelf. So that kind of gives you an understanding how I can apply this directly in Postgres without any external applications. So now that, the agent gets this context before the SQL, let me kind of show you how it changes the output. So let's say I add my agent, hey, simple query, find me a stylish bookshelf. What would happen without context is it will do the naive thing and just do a where clause on stylish bookshelf, return only 8 results. However, since we give a context as to, what a stylish bookshelf is and how to, mess with queries like that, it has that context to know to do a vector search on those results. So kind of gives you a good understanding of, what exactly can happen between when you have context and when you don't. Even if that's good, what starts to happen is I only showed you one retrieval mode. So I added context, which is great. And the retrieval mode that happened was vector search. However, how do we make sure our agent can use all the retrieval modes of Postgres together? So before we touch into that, I want to quickly introduce how I'm going to do that today with HorizonDB. So Azure HorizonDB is what I'm going to be using today to demo to you guys how we connected these things all together. HorizonDB is the newest Postgres offering for my team at Microsoft, and it's built for businesses with everything you need in terms of disaster recovery, workload scalability, so on and so forth, and engineered specifically for developers, specifically with nice AI features that can help you solve this context and retrieval problem. What we're going to touch on today is using extensions that are available directly in HorizonDB, such as pgvector, pgfts, meaning Postgres full text search, pgdiscnn for faster vector search, AG Apache Age extension with some additional advancements we added right in HorizonDB, and then the Azure AI extension, which will let you use AI models directly in your database. So, as I said, one database, now we can do these 4 retrieval modes. Right inside Postgres, we're going to talk about how we do hybrid search, relational SQL search, graph traversal, and re-ranking, all in the database to help answer this question and give, the agent has better context now and it has the right tools to do better retrieval, all in your database, it's pretty natively working. So the first thing I'm going to touch on is kind of explain, okay, so in HorizonDB, how exactly does this hybrid search work? So basically what will happen in Horizon is we would first use the PG full text search to do a BM25 search. This is a similar algorithm you find in, softwares like Elasticsearch. Then the hybrid search also does a, vector search to get this vector similarity. And that vector search runs with the discan and vector index to give you faster, more efficient search on large scales of data. And then lastly, we bring those results together and give you the right output. And if folks were not able to follow that kind of high level, I kind of dig a little deeper to show you the code here. So the first level you see is right in Horizon, we can call the pgfts function, where we can take a subset of the query we put in, do a full text search to find things that exactly meet the criteria. Then secondly, we can use PG vector index with disscann to do a vector search in the query to get more results. And it uses, Azure AI under the hood to call the LLM, the embedded model to do your vector search. And then lastly, we use RRF, reciprocal rank fusion, to take those two separate terms or separate results, join them together, and give you a fused ranking. And then after all that is done, you get your hybrid search. The next thing is graph. So the first tool is hybrid search. You can see how it works. And the second tool we want to use for this retrieval is graph in Postgres. So a quick refresher for folks is the way graph in Postgres works is you can model and query Cypher queries right in Postgres. That's with the Apache Age extension. So this is quickly show you how that works. For example, in this query, I can say, hey, I want to, find the products that frequently are bought together. So this query, what you're seeing is a fairly simple query where the product with the name and what product it was bought with. And then you can do that search. You can do a very simple graph query directly inside Postgres with no extra infrastructure. So that's the second tool that you have. And now you have the hybrid search, you have the graph query, and then obviously we all know how to do SQL queries. We kind of bring those all together, and now your agent can do a blended retrieval to give you more accurate results. So what happens in the first step is agent receives the question, does the context correction, uses hybrid search, SQL filter it, and also the graph query, does a re-ranking, and the re-ranking just gives you the maximized relevance of all the results and spits out the results for your users. So what I'm going to do now is I'm going to show you a very, very quick demo of how exactly this all works together. Okay, so right now I am in my product Copilot database. So the product Copilot, I have vector search on, which will be normal RAG, and then I also have blended retrieval going on. What I'm going to do first is I'm going to go ahead and I'm going to paste in, whoops, sorry about that. I'm going to go ahead and paste in my query. So the query here is the same as before. I'm redecorating my living room. Find me something, a stylish bookshelf under $100 that pairs well. So going to run that query. And when I run that query with vector search, what you can see right off the bat is vector search was good, but however, 4 of those results were over $100. So it didn't abide to my rules. So you can see here, this is over $100. This one is over $100. And if you look through all of them, like, I don't know if it's me or you, but these don't look particularly stylish to me, nor like they're not all kind of bookshelves. So for example, this one's not a bookshelf. So I wonder if we can do something better. So what I'm going to do is I'm going to turn on blended retrieval. I'm going to go ahead and run this exact same search. So we go ahead, we run the same search, and I'm going to show you how the agent works. So right now it's generating the answer, and the agent is calling different tools. First, as I said, it's doing the context correction. Then it calls the different tools that it has available, and it gives you an answer. So to quickly break that down, so what the agent does is it calls the MCP tools. It's able to look at the schema, get the context around what stylish bookshelf actually means, goes ahead and changes stylish bookshelf to mean modern bookshelf storage. With the storage, it's either bookcase, sleek, chic design. It does the hybrid search I talked about, right? And then to see that hybrid search I showed you guys, you can see that all gets run by the agent. After that's run, the agent does a product filter, like I said, says, hey, give me anything under $100. And then after that's done, it then shows you, gets the product details of all the product. You can see this is the top product. And then lastly, it runs a product, what works well. So it does a related graph query on that. So you can see here, the graph query I talked about gets run. And then now we can see the results. Everything is under $100. And also things are a little bit more stylish. So you can see here a green shelf. There is also a blue shelf here. So things are a little bit different. So as I was able to show you right now, like data retrieval is going from just RAG with vector search to something completely different that can do a multi-turn search and give you way more accurate results. So that's kind of the demo I wanted to show you today. And let me go ahead and kind of wrap up here. So, as I said, just quickly recapping is did the context correction for that query, did the hybrid search, did your SQL filter, did your graph query, and then did re-rank. So it's a multi-turn retrieval I'm talking about that cannot be possible with RAG, but an agents can do this and give you more accurate answers. So, as I said, this whole presentation, we went from what RAG agents are, talked about MCP. I talked through all the common issues we use in MCP to query data. I showed you how to do the context correction and the blended retrieval. And now let me just quickly touch on what is next in this space. So, as I told you already, HorizonDB is kind of our next big Postgres offering that does offer a lot of what we built out the box. So what I showed you in that demo, full text search to do the hybrid search, DiskNN, Apache AGE, as well as Azure AI, all packaged in HorizonDB. HorizonDB also gives you access to AI model management, which lets you do all your AI functions hosted right on HorizonDB. You also get access to an MCP connector, so you can connect pretty easily to the tools on the MCP server for you to talk to your Postgres database. And lastly, not least, as a Microsoft product, it's enterprise ready for everything you need. So you don't need any external services to build out these high scale AI apps anymore. You can do that all in one database in HorizonDB. So what is next and how we grow in HorizonDB? What I'll just quickly show you is a recap of in 2024, folks were dabbling in RAG, but it was mainly basic queries. 2025, I talked a lot about RAG and graph. 2026, today, I'm talking to you guys about blended retrieval and MCP. But in the future, we're thinking of making this even easier, having a unified retrieval directly in HorizonDB, where all users may have to do is just say AI.search stylish bookshelf. HorizonDB does all the code work for you, like I showed you, and gives you the right answer. So that kind of shows you where we're going from just queries to agents and maybe something beyond directly in HorizonDB. So if you guys like this demo and what I talked about, I encourage you to go to aka.ms/Posette query agents. Um, 2026. Check out the GitHub repo. Will give you the MCP configurations of how I made this run. Also, the front end code if you want to test it out yourself. I encourage you to test it out and ping me on either X or GitHub, and we'd love to chat. And then if you guys want to know more about Postgres and our AI offerings or HorizonDB, here's some links you can check out. You can check out some of our blogs about AI agents, check out some blogs about our solution accelerators and how you can build some of these functionalities yourself. And you can just look at the whole Azure Postgres blog itself. And that's it, everyone. Thank you guys so much for listening. Kind of walk you guys through the gauntlet of what I've been working on for quite a bit now, of how we're taking simple queries in Postgres to, give you guys, more futuristic agentic retrieval right in Postgres, right in HorizonDB, and how you can build it out yourself and test that out. So feel free to hit me up on any of my socials here, and please go ahead and try out the GitHub repo. Thank you so much.